So what really makes one AI smarter than another? We hear the term AI thrown around all the time, but let's be real, not all AI is created equal. Today we're going to climb what I call the AI agent ladder, and we'll see exactly what separates a simple little thermostat from a truly sophisticated thinking machine. Let's start at the very bottom.
Just think about the stuff you have in your house right now. You've got a smart thermostat, right? It turns the heat on and off. Is that thing really on the same intelligence level as your robot vacuum, which, maps out your entire house and dodges your furniture? Spoiler alert, it's not. And by the end of this, you're going to know exactly why.
Okay, so here's our game plan for climbing that ladder. First, we'll cover the basics of what even makes an AI an agent. Then we'll go from simply reacting to things to actually remembering them. After that, we'll give our agents a mission, a purpose. And finally, we'll see how they can learn and even team up. Let's dive in.
So, what's the secret sauce? What makes an AI smart? Well, the most important thing to get is that intelligence isn't just one big on-off switch. Now, it's something that gets built up, layer by layer, one skill at a time. At its absolute most basic level, an AI agent is just anything that can sense or perceive its environment and then do something or act on that environment. A sensor could be a camera, a microphone, a thermometer, whatever. And an action could be turning a wheel, flipping a switch, you name it. This super simple loop, see something, do something, is the foundation for literally everything else we're about to talk about. All right, we're on the ladder now, right at the bottom. And the first huge leap in intelligence comes from one single critical upgrade, going from just reacting to the world to actually remembering it. First up, we've got the reactive agent. This is the simplest kind of AI imaginable. It basically runs on a simple if this, then not rule. It sees the world as it is right now, and only right now, and makes a choice. It has zero memory of what happened even a second ago. And the classic example is your thermostat. It senses one thing and one thing only, the temperature right now. If it feels it's over 25 degrees, boom, it does one thing, turns on the AC. It has no idea if it was hot 5 minutes ago or freezing all morning. All it knows is the present moment. It's completely stateless, just reacting. And here it is. This is the first major level up on our ladder. You can see it right here. We go from an agent that instantly forgets everything to one that can actually hold on to the past. This one little thing, adding memory, it changes the entire game.
So this brings us to the model-based agent. This guy is way smarter because it keeps an internal model of the world, which is really just a fancy term for having a memory. It uses what it's seen in the past to build a picture of how the world works, which helps it make better decisions now.
Let's go back to that robot vacuum. It is the perfect example of a model-based agent. It doesn't just blindly bump into a wall and turn around. No way. It builds a little map. That's its model of your room. It remembers the spots it's already cleaned, so it's not wasting time. And if you move a chair, it updates its map. That memory makes it so much more efficient and, intelligent than that simple thermostat.
Okay, so our agents can now remember things. That's a big step. The next rung on the ladder is to give them a mission. This is where we start talking about goals.
A goal-based agent isn't just wandering around building a map of the world anymore. It has a destination. It has a purpose. It starts to think ahead, considering different actions and choosing the sequence of actions that will actually lead it to its goal. This requires a whole new skill, planning. We all use a goal-based agent probably every single day. Google Maps. Its goal couldn't be clearer. Get you from where you are to where you want to be. It looks at all the possible actions. Turn left here, take this highway, avoid that street, and it plots the best sequence to get you to your goal. And if a road is suddenly blocked, it doesn't just shut down, it replans. It finds another way to reach its destination. A goal-based agent is pretty darn smart, right? But let me ask you this, is just getting there enough? Or do you want to get there in the best possible way? That question, that brings us to the next level of intelligence. And that brings us to the utility-based agent. This agent is a cut above. It doesn't just find a way to the goal, it finds the optimal way. And it does this by using something called a utility function, which basically gives a score to different outcomes based on what we care about. Things like speed, cost, or even customer happiness. It's all about finding the absolute best trade-off. Think about the system behind a food delivery app. It's a perfect example. The basic goal is simple: get the food to the customer. But a utility-based agent is juggling a ton of factors. What's the fastest route? Which driver is closest and costs the least to use? Which combination is most likely to get a 5-star rating from the customer? It crunches all those numbers to pick the single best, highest utility option out of all the possibilities.
Okay, we are now reaching the very top of the ladder. This is where agents start to feel truly intelligent, the way we usually imagine it. We're talking about agents that can actually improve themselves and even work together as a team.
Now, the learning agent is a total game changer. See, all the other agents we talked about have their logic more or less hard-coded. But a learning agent, it can get better all by itself. It has a special learning element that lets it look at its own performance, take in feedback, and then change how it works to do a better job next time. It literally evolves.
And you see these learning agents everywhere now. Language models like ChatGPT are an obvious one, or the recommendation engine on Netflix that learns what you like. But a really powerful example is a robot that learns to walk. It falls down over and over, but with every single attempt, it learns, adjusts, and gets a little bit better.
And finally, at the very peak of our ladder, intelligence becomes a team sport. A multi-agent system is just what it sounds like, a whole team of different smart agents, all working together, cooperating to solve problems that are way too big or complex for any single agent to handle on its own.
For a really clear picture of this, think of a system like Microsoft's AutoGen. Let's say you want to write a big research report. Well, you'd have one agent whose only job is to go out and find all the data. It then passes that data to an analyst agent, whose specialty is finding patterns and insights. And then finally, a writer agent takes those insights and drafts the actual report. It's like a digital assembly line of pure intelligence.
And there we have it. We've climbed all the way up, from a simple switch that just reacts to a whole team of collaborating digital experts. So let's do a quick recap of the journey we just took. This chart really puts it all together. We started at the bottom with the reactive agent, no memory, no goals, like a thermostat. Then we gave it memory and got the model-based agent, like our robot vacuum. Then we added goals to get the goal-based agent, our Google Maps. We made that even smarter by having it weigh trade-offs, creating the utility-based agent, like a delivery app. And at the very top, we have agents that can learn and team up. Each step up the ladder adds a powerful new capability.
And that's our journey up the AI agent ladder, from the simplest reflexes to complex, collaborative intelligence. It really just leaves us with one massive question to think about, doesn't it? As these agents keep getting smarter and better at working together, what are the really big, complex, world-changing problems that we should ask them to solve next? Something to chew on. Thanks for tuning in.